In this video, I'm going to be modeling in AutoCAD and 3D this fitting, this brass fitting that has a couple interesting parts. It has some stepped down diameters and for rings and grooves for that, and also a hex uh, part to it. So we have some step diameters, a hexagonal fastener part, and I'm going to ignore the pipe threads. We're not going to model those, but I'm just going to get this main fitting drawn with using Revolve command and just drawing the top half of this section, this basic shape along here where my cursor is following, and we're going to use AutoCAD to do it. So here we go. In the front view port, I'll start drawing some circles. I'll put them at the origin. This first circle is going to be the diameter of the left end, so I'll put the two left side diameters, the 1.05 diameter and the half-inch diameter on the left, and then I'll have these three diameters on the right. So this one's 1.5 or 1.05, and the half-inch diameter. Now this part is 3.5 inches long, so off to the right with my next circle, I'll give it a good 4.5 or 5 inches and draw 0.75. I think this was 0.625 and 0.312. Okay, now with the polyline, well, with the regular line, I'll just draw a 3.5 inch line so I can have a place to start and end. So now with the polyline, I start at the top of the half-inch, my starting point, come up to the 1.05 inch diameter. This distance is 1 inch plus the 0.15, which is where the thread stops and where the hex starts, and then another half inch for the hex. So that's all going to be one straight line, 1.65. It adds up to feet. And it's going to step down to the 0.7 or the 3/4 inch diameter for 1 inch. And then it's going to step at 60 degrees. It says from the vertical, but really that's 30 degrees from the vertical, or 60 degrees from the horizontal, actually. And it's going to step down to the 5/8 diameter. So following, maybe zooming a little bit would help. Tracking along there until I get my 60 degrees. And this is 35 hundredths in length. Then it steps back up at 60 degrees, back to the original. And this is 8 hundredths. Stepping back down, and then off to the end, which I have right here. This goes down to the hole. And this hole is, don't know how long, I only have this 1.75 inch length to gauge that with. So I'll start again at 1.75, and this steps at 30 degrees from the horizontal to the 0.312 diameter, and then closes. So I need to join these two together. There's only one other thing left before I revolve, and that is to chamfer the ends. This has a 45-degree chamfer of 9 hundredths, and this has a 45-degree chamfer at 6 hundredths. So distance of 0.09, distance of 0.06, There, I'm ready to revolve this part about the center line, that would be the center of the hole for 360 degrees. And there's the round parts of the fitting. Now off to the hexagonal portion of the fitting. If I can use my polygon command, it may not be a very good idea to draw it this way because it's not going to be aligned, although I certainly could revolve it or rotate it. So that's 1.5 inches across the flats, so 0.75 inches this way, and at this point I want to revolve it 90 degrees so it's in the right place. At this point, well, let me check it in the front view just to be sure. There it is. Now I'll extrude it back 1/2 inch. And that is a 1/2 inch width of that hex nut shape. Now the shape is chamfered also, so it's actually, the chamfer tool won't work for it because it's chamfered along a circle, not along each edge. So it's actually not chamfered at the midpoints of each side. So the way to accomplish that would be another polyline. So if I can track from the midpoint here at 120 degrees upwards, and then come down to any point here and track, go right to the top of the center. That would work. Go all the way through. Doesn't have to go all the way through the fitting. In fact, I would rather hide the fitting on a different layer, but this will work too. And then come back up. Don't have to make that straight, but that works fine, and then close. So this shape, I'll go ahead and hide this fitting. I have a temporary layer for it, and then I can freeze that temp layer. So this shape here needs to be revolved around, well, I need to move it first to the midpoint. So at this point, revolving this part will cut a hole, and subtracting it from the hex nut will cut a hole in the center of it and chamfer along a circle the right side of this hex nut. I'll mirror this over. I can do that after. It can be done either way. So revolve around the center, and that's the shape that's going to be subtracted from the extruded hexagon. And I'll mirror it in the front view. About the middle, so I can revolve, or I can subtract both of these now. So it might look a little weird, but this is what it looks like after subtracting. Kept in wireframe, it's a little easier to see how to select the objects. So there's the chamfered hex, outer part of the hexagon, and the hole is cut into it. So a nice hex nut. This is a nice way to make a hex nut, by the way. So now all I got to do is turn on the fitting, solid union these two pieces, and there's my hex nut, or there's my fitting. The best way to dimension this and to show it in a multi-view drawing is to make a full section of it. So if this is the top view, which makes a fine top view, I'll place it here, and I'll just make a isometric view of it as well, and that's all I'll make in there. And then but in the layout view, I'm going to add a full section view of this part. Tracking, if I can track. Not sure why it won't do that, but that's okay. And there's the, just a bit more. There we go. And I can hide the MD annotation layer to not have to show the cutting plane because it's obvious it's being sectioned along its center. At this point, I can dimension the interior dimensions, such as this 30-degree angle and the 2 diameters of the holes, and as well as the outer diameters. Perhaps a right side view would be useful to dimension the hexagon, but that would be the only thing that would be necessary. I could put a leader to that hexagon and be done with it with these 2 views after dimensioning. So there you have it. That's how a nice revolve can chamfer the hex nut as well as produce all the circular features of the fitting.